Hey, welcome everyone. Brain, the most important part of our body, which controls our thoughts, memory, speech, and most importantly, breathing. But brain tumor, which is one of the most dangerous disease, affects our brain. Every year, thousands of people die because of it. First, let's understand what is brain tumor. Tumor can be defined as the abnormal growth of the tissues. This mass grows within the skull. Because of that, normal brain activities are hampered. If it is not detected at an early stage, it can take person's life. So, the question arises, how do we detect it at an early stage accurately? We can run tests and biopsy, but one more way is to detect it through the MRI scan. Most tumors are clearly visible in it, but sometimes it is not that easy. The manual identification of brain tumor MRI image is subjective in nature and may vary from expert to expert. So, here we are proposing an automated identification of brain tumor with convolution neural network. Let's go through the demonstration. Here it is. Just one step, upload the image and rest will be done by our model. Let's upload the image, and I'm uploading the image which has brain tumor, and here we go. So model is 100% sure that it has brain tumor, and so are we. So let's take another example. This time I'm uploading the image which does not have brain tumor. So let's upload it, and here it is. 0.47% probability only, and it also says that there is no need to consult a doctor. Now let's jump into the architecture. We had downloaded the dataset from Kaggle. It contained only 253 images, and to train the neural network it was really small and imbalanced. So we did data augmentation to get a large dataset. What data augmentation does is it takes the image from the original dataset and tilts it, rotates it, flips it, or brightens it and creates new images. For every image which has brain tumor, we created 6 other images, and for every image which does not have brain tumor, we created 9 other images. We will discuss data pre-processing later in video. Let's come to data splitting. We use 70% of the data for training and the model and rest 30% for testing it. Before training the model, we went through several layers of neural networks, which I am going to explain later in this video. And here it comes, the last stage, training the model. We have trained the model built with this neural network layers and tested it with batch size 10 and different number of epochs. While training, we saved the model which gave us the higher accuracy. Let's understand the pre-processing in detail. It includes 4 processes. The first step is image contouring. It is the process of identifying the structural outlines of the object. It helps in identifying the shape of the image. After that, it crops the image so that we don't have to deal with unnecessary data. All the images in the dataset are of different sizes, so we resize them, and in the last we normalize them. Let's dive into neural network layers. First is zero padding. While convolving through image matrix of 4 cross 4, the size of filter is of 3 cross 3 and we are moving one column or row at a time. The output is reduced to 2 cross 2 matrix. This is the loss of data. To stop this, we add extra rows and columns of zeros so that while convolving through image, we can prevent data loss. The convolution neural network is a specialized type of neural network model designed for working with multidimensional image data. A convolution in context of CNN is the simple application of a filter to an input that results in a feature map. The innovation of convolution neural networks is the ability to automatically learn a large number of filters in parallel specific to a training dataset. In a neural network, the activation function is responsible for transforming the summed weighted input from the node into the activation that is output of the node. The rectified linear activation function, or ReLU for short, is piecewise linear function that will output the input directly if it is positive, otherwise it will output 0. ReLU prevents losing information. Max Pooling reduces the dimension of the image. The filter convolves through image and selects the maximum element from the covered region. It helps solving the issue of overfitting. In this image, the metric is 4 cross 4 and filter is 2 cross 2. If we put stride equals to 2, it will move 2 cells at a time and will get output as 2 cross 2 matrix, which is reduced in dimension. Till now, we have seen all the important processes and layers of the model. This model will help doctors predict brain tumor more accurately. Thanks for watching.